Hello everyone, I am Shomesha Shanavati, Assistant Professor of Civil Engineering at Vedang Institute of Technology. So today in this class we will solve some most probable questions of Structural Analysis 1 from 4th semester of Btech Civil Engineering syllabus. So here is the first question that consists of Maxwell's reciprocal deflection theory. So Maxwell states that when we have a beam and we have the point load at C, the deflection at any point in the member, or you can say at D, will be equal when another point load occurs at any other point and the deflection will be same at point C. Okay. So here, if unit load is at point C and we take the deflection at point D as delta DC, that will be equal to when point load is at D and the deflection taken at point delta CD. Here is the Maxwell's reciprocal deflection theory. Okay, here. Next is write the equilibrium equation for three-dimensional analysis. We know that in case of three-dimensional analysis, the force in all three directions and the moment in all the three directions need to be 0, and the sum of all the forces or the sum of all the movement will be equilibrium. We can take with an example. Here let's make a three-dimensional diagram. When we take the stresses, we need to have the type of stresses in our mind, that we have normal stress and what? Shear stress. Okay. So in x direction, here we will have the normal stress, let f of x. Okay. So here we can have in x direction that sigma x, let it be as sigma x. So here it will be sigma x plus del sigma x upon del x into dx. Okay. Similarly, if in y direction we have sigma y, in another direction we will have sigma y plus del sigma y upon del y into dy. Similarly, here in z direction, if we have here sigma z, at this we will have sigma z plus del sigma z divided upon del z into dz. Okay. Here we only talk about the normal stresses. Now we will consider about the shear stress. So here sigma x we will have in y direction tau xy, and in z direction here we will have tau xz. Similarly, here we will have in y direction tau xy plus delta tau xy divided upon del x into dx, as it is in x direction. Next, in z direction we will have sigma xz plus del sigma xz divided by del x into dx. Similarly, we will have the forces in y direction as well as in z direction. So when the plane is in equilibrium condition, so the stresses will be equal. Okay. So the addition of or sum of these forces or movement, first forces, then we will take the movement, that will be 0. Okay. So in 2-mark question, we only need a simple diagram and to write these things. Okay. So in our third question, it consists with state the principle of minimum potential energy. Okay, I need to draw this again as this is not visible. Here we have a simply supported beam. Okay, so the beam changes or it will deflect when the external forces will be maximum than the internal force, or the internal force is not capable enough to resist the external force. So it will deflect then. Up to that point, it will be in equilibrium condition. So when it will start deflecting little bit, that will be termed as the minimum potential energy. The energy required to deflect minimum amount will be termed as your minimum potential energy, or you can say the principle of minimum potential energy state that for conservative structural system. What is a conservative structural system? When your structure is fixed at both the ends, that will be termed as your conservative structural system. Okay, and the actual deformation that satisfies the boundary conditions. What is the boundary condition? The boundary condition is not, is it that external force will be equal to internal force. Up to that point, it satisfies the boundary condition. Then when it changes or internal force is not capable enough to resist the external force, that point, what? The minimum potential energy arises. Okay. Kinematically admissible deformation. Kinematically admissible deformation in the sense there will be little changes. First, here in this diagram, this one structure here, the deformation is little. Again, after applying more load, again the deformation will change. So, this is the example of minimum potential energy. In our next question, what? The Castigliano's first theorem for determining deflection. So it states that what? The deflection at a point on a structure in the direction of a given load is equal to the partial derivative of the total internal strain energy with respect to that load. Let's start drawing a structure. Here we have a structure, let it be simply supported. Okay. So, what? The total internal strain energy we need to find out. Let U be the total internal strain energy. So, the formula will be del U upon del P. Upon what? Upon the given load. Let the load will be P. So, del U upon del P will be your deflection. You just need to give the definition and write the formula. You will get 2 marks from this question. And here, differentiate between simple truss and complex truss. We all know this, but we generally did not define this. So what is a simple truss? So simple truss is generally consist with member and joints. Here you can see, in case of truss, we generally need two things. One is your member, M for member, and here J is your joints. a structure is a triangular element and we can calculate the members and the joints easily, that will be your simple truss. Let's have a diagram of simple truss. This is a simple truss. You can calculate the member, you can calculate the joint. Member is what? These are the members. Here you can see the joints. But what is a complex truss? When the members are not visible properly or the members are overlap with each other, then that truss will be termed as your complex truss. Let's we have an example like I am drawing these examples because from diagrams we can remember easily. If you just see this video, so you can, by watching this diagram, you can remember easily that this question is filled with this. Sorry. So a complex truss will be look like this when the members itself and the joint is not properly visible. You can see the overlapping structures here, and it will look more complex when you cannot find that it is a simple structure, simple truss or compound truss. So that time you can, so this formula is complex when we have a complex truss. Okay. So next question, write advantages of arches over beam. First thing, what is an arch? If we have a column and the structure is look like this, it is your what? This is your arch. If a structure is with a beam, it will look like this. Both are simply supported. So you can see if, what is the difference generally? We can say the difference is wider in space. You can see this structure is wider and it can take more load than the normal beam. Here, arches transfer the wall load by compression. So here you can see compression, the load is compression, and in case of beam, the load is in tension. Another thing is carried blocks of brick or stone, or we can use the break. We can use the breaking stones or the blockage in case of arches. Okay, and they can span much wider, as I have already said, because they can be made from small little bricks or broken bricks. So next question is different element of a suspension bridge. When you listen about suspension bridge, you have a thing in mind that what is a suspension bridge? Suspension is bridge nothing but like this. It is generally connected with cables. So this, when you say we are on a bridge, that is not a bridge, that is the deck. And these are the suspenders. These lines are the suspender. Here the wires, you can say the cables, these are the vertical suspenders. Okay. And here this small thing you can see, this is nothing but your abutment, and it holds all the load, and this is connected with the deck by anchorage. Next is your main suspension cable. Here you can see this is going like this from a structure to another column. This is going like this. This is your main suspension cable. And from one tower to another tower, the distance is main span length. Okay. The basic structural component are main suspension cable, vertical suspenders, anchorage, abutment, and deck. Okay. You can draw this diagram for getting more marks. Next is your what is defined influence line diagram. Generally we say it as ILD. What is ILD? You can clearly think that we know the shear force and bending moment diagram. Okay, here is a point load P and a beam of AB. So, in case of AB having a point load P, the shear force and bending moment diagram we can done with respect to the supports. But in case of calculation of influence line diagram, what will change? It will changes the points of load. The load point will vary from points to point in case of in that beam. As it says that the reaction axial force or shear force or bending moment in a diagram will change. That is your influence line diagram. Generally, you can remember that in case of shear force and bending moment, the supports will be fixed. Sorry, the supports will change. But when we think about ILD or influence line diagram, the point load or the unit load will be changed. So, next is your normal thrust and radial shear of a three-hinged arch. Let's go for a three-hinged arch. Yes. So, okay. Here we have a arch. If we draw a tangent with respect to this point, okay. When we draw a tangent to a three-hinged arch, the forces across the tangent is termed as your normal thrust. Okay. Similarly, when a perpendicular force will be applied to the tangent is termed as your radial shear. By this diagram, you can remember that forces across the tangent is your normal thrust and the force perpendicular to the tangent is your radial shear. Next is your conjugate beam. So when we go for the conjugate beam, we need to have in your mind that it is completely opposite to the real beam. So with an example, here we have a fixed beam. Here you can see this end is fixed and another one is your free. So conjugate beam is nothing but the complete mirror image of a real beam, and the conjugate beam will be the mirror image of the real beam. Here. This will be a free and this end is the fixed end. Okay. So the conjugate beam is nothing but is a formula or a method to find out what? The slope and deflection of a beam, and you need to just remember that if a support or in case of conjugate beam, it is complete opposite or mirrors image to the real beam. With another example, we can understand this. So, if another beam is, the one end is roller support and another end is your hinge support in real beam. So, in case of conjugate beam, this end will be your hinge beam and this support is your roller support. Okay. So, conjugate beam defined imaginary beam with the same dimension as that of the original beam. The dimension will not change. If the length of the beam here is L, this length is also L. Okay. But the load at any point on the conjugate beam is equal to the bending moment at that point divided by EI. EI is what? We take here M as your bending moment and EI is nothing but your flexural rigidity. Okay. So here in case of conjugate beam, the load is bending moment with respect to flexural rigidity. Okay. So here in this class we have solved 10 questions, that is most probable questions from structural analysis part. In our next classes we will solve lots of questions of another subject. Thank you so much.